Question 3. At a national park, a network of 9 trails connects 6 rest areas. The vertices of the graph below represent the rest areas, and the edges represent the park's trails. The park administration decides to add 2 new trails. Once these trails are open, a hiker will be able to start and finish a hike at the same rest area by walking along each trail only once. Which rest areas could the 2 new trails connect? Remember the Euler paths and Euler circuits? All vertices are of an even degree, and the path starts at any vertex and ends at the same vertex. That's an Euler circuit. Or we can have exactly 2 vertices with an odd degree, and the path starts at a vertex of odd degree and ends at the other vertex with an odd degree. And remember, Euler is all about the edges. So that's what we're doing here. Notice P has an odd degree. We want to hit every single path. We want to have an Euler circuit. But if we have an odd degree, P, and we have an odd degree, U, then it can't be done. You'd have to start at P, go around as much as you could, but you would end up at U. Or if you started at U, you could go around as much as you could, but you'd end up at P. So you cannot have any vertices with an odd degree if you want to have an Euler circuit. So we're going to have to connect the P and the U to something. Here we're attaching the P, but we're not attaching the U to anything. Here we're attaching the P, and here we're attaching the U. Here we're attaching the P, no U. Here we're attaching the P and no U. So in B, we're attaching the P to Q and the U to Q. The answer is going to be B. Let's have a look at that. So the P attaches to Q and the U attaches to Q. So let's start at P. So we're going from P to U, from U to Q, from Q to P, from P to S, and from S to R, from R to Q, from Q down to R again, and from R up to U, and from U to T, and T to S, and S to P. So we started at P and we ended at P. Once these trails are open, a hiker will be able to start and finish a hike at the same rest area by walking along each trail only once. An Euler circuit. And that's it for question number 3. Have a good day.